Hi, my name is Dan Benoit.
And I'm Xiaolin Chen. Welcome to this installment of our video blog, Casual is the New Formal.
So ever since formal property checking was first adopted in our industry, people have been asking the question, how do I know when formal verification is complete? In simulation, this question is usually answered by measuring coverage. When the simulations reach a specific coverage completion goal, we sign off on the functional verification. So we need something like that for formal. So Xiaolin, where should we start?
Well, the obvious place to start is test plan coverage. If we wrote a good test plan and we implemented and proved properties to cover all of the test plan elements, then we have a pretty good argument for completeness. A set of properties is similar in many ways to functional coverage model for simulation. But beyond that, we need automatic metric that can identify coverage holes in our property set. What do you think?
Oh, I totally agree. But fortunately, there are several metrics that we can use to assess a formal setup for completeness. The easiest and least expensive is probably the cone of influence analysis. We know that a property cannot possibly verify any logic that's outside of the transitive fan-in of all the signals it is monitoring. So by computing the union of the fan-in cones for all of the properties, we can determine if there's any logic that's outside of all those cones. If there is, then we definitely have a coverage hole and more properties are needed.
That's right. We can also combine this cone of influence analysis with the measurement of a distance between the property and the design code. For example, we might consider only logic that can affect a property within 1 or 2 clock cycles to be covered by that property. Without such a sequential distance limit, the COI analysis might be way too optimistic about the property coverage.
Right. So another metric we can use is abstraction coverage. Some formal solvers use abstraction or structural partitioning of the design to increase the proof capacity. After a property is proven, the engines may report on the extent of the design partition needed to solve that proof. Any bugs in the design code that are outside of that partition cannot be detected by the property. So by combining the abstractions for all the proven properties, we can expose logic that is not in any partition. This also points to more property coverage holes.
And if you want even more detailed coverage analysis, we can use tools that can automatically inject bugs into the design and then check if any of the properties can detect those bugs. So VC Formal working with Certitude can identify specific design corruptions that cannot be detected by any of the properties. And this will guide you to create additional checkers to cover that hole. So in practice, however, we reserve this technique for extremely critical and complex subunits because it can be really resource intensive. Many properties must be checked against many different bug scenarios. But the value of this analysis can be extremely high though.
Yeah. So what about cover properties? Do these have a role in measuring verification completeness?
Absolutely they do. Cover properties in formal can tell you if certain design states or behaviors can be reached, right? And then this can be very useful for finding bugs either in your design or in your formal environment. If some expected behavior is reported as unreachable, something is obviously wrong.
Right.
But formal coverage targets alone do not ensure that your design is working properly. You still need checkers to validate all expected behavior can occur.
Absolutely.
And all the illegal and incorrect behavior cannot occur.
Yeah. So we hope that this discussion started you thinking about how to measure formal completeness on your design. And thanks for joining us for this installment of Casual is the New Formal.
See you next time.
Bye.